Hi, I'm Orina DaCosta from Fusion Quill. Welcome to our video series on AI education. Welcome to our exploration of generative AI. We'll take a look at various AI architectures, get a glimpse into the ethical challenges, and take a look at what the future of generative AI holds. Let's dive in. Today, we'll explore the world of generative AI. But before we get to that, let's talk about what exactly is AI. Simply put, it's a suite of technologies that are designed to mimic human intelligence and capabilities, enabling machines to perform tasks that typically require human insight and decision making. Today, we'll be focusing on generative AI. This is the creative side of artificial intelligence. Generative AI is about making something new, whether it's a block of text, a piece of music, a digital image. It's AI that doesn't just analyze data, but uses it to create outputs that might seem like they were crafted by human hands. Imagine you're at a fancy art gallery admiring a beautiful painting. Now imagine if that painting could be created not by a human artist, but by a computer. That's the magic of generative AI. In simple terms, generative AI is a type of artificial intelligence that can create new content, like images, music, or text, that's so convincing you might think a human made it. Get ready for a quick history lesson. I promise to keep it short. Our story begins in the mid-20th century, a time of foundational ideas. The creation of the perceptron in 1958 marked one of the earliest forms of neural networks, setting the stage for what AI could eventually become. As we move into the 1980s and 90s, the development of backpropagation allowed for the training of deeper neural networks, laying the groundwork for more sophisticated AI models. This period saw the first experiments with systems that could generate simple patterns and sequences, hinting at the potential of AI to create rather than just analyze. The 2000s brought about the deep learning revolution. Advances in hardware like GPUs, along with innovative algorithms such as convolutional and recurrent neural networks, propelled AI forward. During this era, the accumulation and availability of big data played a crucial role in training increasingly capable models. The real breakthrough came in the 2010s with the introduction of generative adversarial networks by Ian Goodfellow and his colleagues in 2014. This, alongside the rise of variational autoencoders, allowed for unprecedented progress in generating complex and detailed content, from art to text. A pivotal moment in AI development occurred when the paper "Attention is All You Need" was published in 2017, introducing the transformer model. This model revolutionized natural language processing by relying solely on attention mechanisms rather than recurrent processes, enabling much more efficient and effective training and handling of sequences. Today, in the 2020s, generative AI is not just a field of study, but a practical tool impacting multiple sectors. From the creation of realistic images with tools like DALL-E to sophisticated text generators like GPT-3, generative AI is reshaping how we interact with and conceive of creativity and production. And as we look to the future, the possibilities are boundless. To use generative AI, the model needs to be trained. The trained model is then used to generate output based on user inputs. Think of a generative AI model training process as a student reading many textbooks. Over time, the student learns patterns, rules, and relationships from the content in those books, but doesn't memorize everything word for word. Imagine a young child learning to brush their teeth for the first time. They watch intently as their mom demonstrates the proper technique. Curious and eager, the child picks up the brush and starts to mimic what they have just seen. Their initial attempts are clumsy, perhaps even a bit off the mark, but with each observation and repetition, their movements become more confident and precise. This everyday scene beautifully mirrors the training phase of a generative AI model. Just as a child learns by watching and imitating, our AI models learn through a similar process. They observe or analyze countless examples fed into them. These could be images, text, or any form of data. Through sophisticated algorithms, the AI begins to recognize patterns and structures within this data. During its training, the AI model adjusts its internal mechanisms, much like tuning a musical instrument, until it can replicate these data patterns accurately and reliably. The end goal? To produce new data that's so convincingly real, it's like the flawless brushstrokes of our young learner. The quality of AI's output, similar to a child's brushing technique, depends greatly on the examples it learns from. That's why data scientists are meticulous in curating diverse and comprehensive data sets, ensuring that AI not only learns well, but learns right. In essence, just as a child transforms from mimicking to mastering through practice and guidance, our generative AI models evolve by training on rich data sets, setting the stage for innovations that can enhance, automate, and transform our world. Picture a musician, guitar in hand, stepping onto the stage. With a confident smile, they begin to strum. The first few chords are familiar, practiced, a foundation laid down through countless hours of rehearsal. But as the melody progresses, something magical happens. The musician starts to improvise, weaving together notes in ways that are fresh and exhilarating. Each performance is unique, showcasing not just skill, but also creativity and personal expression. This scene perfectly encapsulates the generation phase of generative AI. Just like our musician who draws from their knowledge of chords and techniques to create a new piece of music, generative AI, after its rigorous training phase, is ready to perform. It takes the vast patterns, structures, and lessons learned from the data it was trained on and begins to generate new, original content. Whether it's writing an engaging article, designing a visually stunning graphic, or composing a soul-stirring piece of music, the AI now uses its learned skills to create something truly unique. The beauty of this phase lies in the AI's ability to not only replicate but innovate, much like a live performance where no two renditions are exactly the same. Each output of generative AI is a testament to its ability to not just mimic, but to add value, to surprise, and to inspire. Let's talk about the different architectures of generative AI. Imagine stepping into an art studio where two artists are engaged in a creative challenge. One of them is a painter, the generator, whose role is to create stunning artworks from scratch. Across from them is a critic, the discriminator, whose keen eye evaluates each piece, determining whether it is a real or a fake. As the painter works, each stroke is influenced by the feedback received from the critic. If the painting is easily distinguished from a real painting, the critic points out the flaws and the painter goes back to the drawing board. This cycle repeats, with the painter continuously refining their technique based on the feedback. This is an analogy for how generative adversarial networks operate. The generator creates, the discriminator reviews. The goal? To enhance the paintings, or in the case of AI, the generated content, so effectively that the critic can no longer tell the difference between what's created and what's real. Each round of feedback makes the generator more adept, leading to incredibly realistic and precise outputs. In this analogy, both the generator and discriminator are neural networks that are being trained. Let's look at how a variational autoencoder processes and learns from data. Here we have a photograph of a bird. This is our starting point, the complex detailed data that our variational autoencoder will learn to encode. Next, the variational autoencoder identifies basic shapes within this image, simplifying the complex image into its key visual components. In the next step, the variational autoencoder not only captures these essential forms but also incorporates a measure of variance. This ability to inject variability is what allows the variational autoencoder to not just replicate but creatively enhance its reconstructions. Finally, using these encoded shapes with added variance, the variational autoencoder reconstructs the image of the bird. The inclusion of variance allows the model to generate new, unique versions of the bird, each slightly different from the last. While these reconstructions may not capture every detail of the original, they demonstrate how well the variational autoencoder can interpret and reimagine the fundamental features of the bird. This cycle of encoding with variance and decoding exemplifies the power of variational autoencoders not only to compress and understand data, but also to generate diverse and innovative outputs. Next, we are going to look at transformers. First, we start with our input sentence, the sentence we want to translate. The transformer is a neural network which has two main parts, the encoder and the decoder. The encoder takes a good look at our English sentence. It's like a detective with a magnifying glass, examining each word and understanding how they all fit together to mean something. It doesn't just look at the words one by one, but sees them as a whole picture, capturing all the details about how the individual pieces connect to one another. After the encoder has figured out the deep meaning of our sentence, it passes on its clues to the decoder. Think of the decoder as a puzzle master. It receives a box of puzzle pieces from the encoder, each piece representing a bit of information about our sentence. The decoder's job is to put these pieces together to form a clear picture. But this time, the picture needs to be in French. It carefully places each piece, ensuring that each word fits perfectly until the output sentence emerges. Transformers can transform more than text. They are used in image processing to recognize and describe pictures, in music generation to create new tunes, and even in video games for making smarter non-player characters. GPT-2 and GPT-3, which stands for Generative Pre-trained Transformer by OpenAI, are based on transformer architecture. Let's look at the world of diffusion-based models visualized through the art of sculpture. First, we start with a block of marble, our initial random input. Imagine this block as the very beginning of our process, where everything starts as random noise. Like the potential hidden in the marble, our model holds the potential to create something extraordinary from this randomness. We move to iterative sculpting. Picture a skilled sculptor, chisel in hand, beginning to chip away at the marble. With each strike, pieces of the marble fall away, slowly revealing the form hidden within. Similarly, our diffusion model methodically removes layers of noise in each iteration, gradually refining and defining the data structure, just like the emerging statue. Next, we reach the refinement phase, where the sculptor polishes the statue. This step is about perfecting and enhancing. The sculptor smooths the surface, sharpens the details, and polishes the figure to perfection. In parallel, our model undergoes further noise reduction, enhancing the clarity and quality of the output, ensuring that every detail contributes to a coherent whole. Finally, we arrive at the final output, the completed sculpture. Our diffusion model has transformed random noise into structured, meaningful data. The final output is detailed, clear, and precise, fully realized from the potential we started with. Through this analogy of a sculptor creating a masterpiece from marble, we can see how diffusion-based models shape and refine data, turning the chaotic into the defined and the random into the deliberate. It's a process of continuous transformation, iteration by iteration, until the final masterpiece is revealed. DALL-E, Midjourney, and open source Stable Diffusion are diffusion-based models. Imagine an AI who has studied from the great masters and philosophers of our time. This is the kind of inspiration and innovation Gen AI brings to artists, musicians, and writers around the world, pushing the boundaries of creativity to new heights. Moving on to improving efficiency. In the fast-paced realm of business and commerce, generative AI can autonomously craft engaging product descriptions, tailor marketing content to captivate specific audiences, and even design cutting-edge fashion pieces. The impact? By automating these creative processes, generative AI enables humans to focus on more strategic tasks and focus on providing creative human input where it truly matters. Lastly, let's explore its role in advancing science and technology. Generative AI can model and simulate complex systems, paving the way for groundbreaking research and technological innovations. From accelerating drug discovery through detailed simulations of molecular interactions to refining climate models and predicting weather patterns, generative AI serves as an indispensable tool for scientists and engineers. It enables faster, more accurate predictions and innovations, transforming how we understand and interact with the world. In summary, generative AI is not just about improving methods, it is helping us redefine possibilities across creative, commercial, and scientific fields. Let's dive into the misuse of AI. First, let's talk about deepfakes. Generative AI has the capability to create highly realistic and convincing images, videos, or audio recordings that mimic real people. While technically impressive, these can be used to spread misinformation, manipulate public opinion, or even harass individuals. The risks raise a profound ethical concern. Moving on to content forgery. With the power to generate text, art, and other media, generative AI can unfortunately also be misused for intellectual property theft, plagiarism, or producing counterfeit documents. This poses serious challenges to copyright and authenticity verification, impacting creators and the integrity of digital media. Next, we have bias amplification. If the training data for generative AI contains biases, these biases can be perpetuated or even amplified in the AI's outputs, leading to unfair automated decision-making, reinforcing stereotypes, and engaging in discriminatory practices. Such consequences highlight the critical need for bias-free training data and ethical AI development practices. Lastly, let's consider privacy concerns. Generative AI systems learn from vast amounts of data, and there's a risk that they might inadvertently expose personal information, especially if the data isn't properly anonymized. The potential for privacy invasion is significant and poses a threat to individual privacy rights. As we continue to advance in the field of AI, it is crucial to address these risks with stringent ethical standards, robust regulations, and a commitment to responsible AI use. Let's look to the future generative AI unlocks. First up is personalized content. Imagine waking up each day to a digital world that understands you perfectly, where every article, song, and digital interaction is crafted just for you. Next, let's journey into virtual worlds. Picture yourself stepping into a video game or a virtual reality experience where every element, from the characters to the landscapes, is dynamically generated by AI. These immersive experiences could fundamentally transform entertainment, training, and education. Moving on to automated creativity. Beyond assisting human creativity, generative AI can now produce original works of art, literature, and music without direct human input. This breakthrough might lead to new forms of art and cultural expressions. Finally, we explore AI as a collaborative partner. Generative AI is evolving from a simple tool into a true collaborator. Imagine AI partners that suggest optimizations in engineering designs, propose strategies in business, or co-develop research hypotheses in science, fundamentally transforming professional landscapes. As we look forward to these advancements, it becomes clear that generative AI is shaping up to be one of the most impactful technologies of our time, promising to redefine our interactions with the digital world and beyond. Thank you for watching this video on generative AI. I would love to hear your thoughts. Let me know in the comments below what videos you would like to see next. And if you've enjoyed the video, don't forget to give it a like, subscribe to the channel, and hit the notification bell so you never miss an update.